Hello everyone and welcome to Geometry Lesson 2-1, Segment Bisectors. You might be familiar with the term bisect. The prefix bi means to, and sect comes from a Latin word that means to cut. Then bisect means to cut something into two equal parts. I bet you can use that information to make a hypothesis about the rest of the terms in this lesson. Segment bisectors work hand in hand with midpoints. You can't have one without the other. A midpoint is a point on a segment that divides the segment into two congruent segments, or equal parts. A segment bisector, on the other hand, is a segment, ray, or line that intersects the segment at its midpoint. So the place where a segment bisector crosses the segment is called the midpoint. Again, remember, bisect just means to cut something, in this case a segment, into two congruent parts. So let's say I have line AB, and then my midpoint M will be in between A and B, so that segment AM is congruent to segment MB. Then any segment, ray, or line that crosses through point M is a segment bisector of segment AB. Any one of those three lines could be a segment bisector. So let's look at how to find that midpoint. To find a midpoint, we use the midpoint formula. It says that the midpoint of the segment connecting points A, x1, y1, and B, x2, y2, is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So when you're given 2 points and you're asked to find the midpoint of the segment that connects them, you can use this formula. You just take the two x values and add them together, and then divide by 2. Take the two y values, add them together, and divide that by 2. We'll come back to using the midpoint formula in a little bit. For now, let's use the definition of a segment bisector and a midpoint to find the lengths of a few different segments. In this first diagram, we're given segment RS with midpoint M. We know the whole segment RS is 34, and we're looking for the length of segment RM. If we know the whole thing is 34 and those two smaller segments have to be congruent, then we know that segment RM has to be the whole segment, 34, divided by 2, or just 17. Now let's look at another example. Here we have segment AB with M as its midpoint, and we know that segment AM is 9, and we're looking for the length of segment AB. Since we know that M is the midpoint, we know that segment AM has to be congruent to segment MB, so they have to have the same length. We also know that segment AM is half of segment AB, so if I double the length of that segment, I can get the length of the entire thing. So we'll just do 2 times 9, the length of AM, and we'll get 18. In this problem, we're told that line R is a segment bisector of segment FH, and then we're asked to find the value of x. So if R is a segment bisector, that means that the two segments on either side of the intersection both have to be congruent, and that intersection point would be our midpoint. Since we know that those are congruent, we can set their lengths equal to each other, so we'll have 9x equals 36. Dividing both sides by 9 leaves us with x equals 4. Now let's go back to that midpoint formula. So here we're given 2 points and we're asked to find the midpoint of the segment. So remember, the midpoint formula is just x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. It's important to remember that when you're finding a midpoint, you're actually going to get another point, so you should have one x value and one y value separated by a comma when you're done. It's a good idea when you're working with problems like this to label your points first. So I'm going to label point G x1, y1, and point H I'll call x2, y2. Then I can easily see where those numbers need to fit into my equation. So x1 is 4, x2 is negative 3. Then I just need to divide both of those by 2. Then we'll go over to our y values. y1 is 0, y2 is negative 1. And again, we'll just divide both of those by 2. Now go back to your x values to simplify this. 4 plus negative 3 is 1, so we have 1/2. 0 plus negative 1 is negative 1, so we'll have negative 1/2. And those are the coordinates of the midpoint of that segment. In our next example, point G has the coordinates negative 2, 3, and H has the coordinates 4, negative 8. Again, we'll label G x1, y1, and we'll label H x2, y2. Then we'll just plug them into the midpoint formula. So x1 is negative 2, x2 is 4. Those need to be added and then divided by 2. For the y values, y1 is 3, y2 is negative 8. They need to be added and divided by 2. When we simplify this, negative 2 plus 4 is 2, so we'll have 2 over 2. 3 plus negative 8 is negative 5, so we'll have negative 5 over 2. Now you can simplify this one a little bit more, since 2 divided by 2 is just 1, and we'll leave that as negative 5 halves. You could also write negative 2.5. That's all for lesson 2.1. Remember, you can go back and review any parts of the video if there was anything that you didn't understand. Thanks for joining me, and happy hypothesizing.